Okay, we are going to, I'm going to turn my light on first. We are going to continue with this one more time in my ongoing effort to milk as much as I possibly can out of this project. So we are going to be doing, I've got quite a few exciting joystick related projects coming up. So there's going to be a lot of these videos. And many other videos. Alright, what am I going to say? Well, what I've got tonight is, to finish it all off, some more joysticks, and this one's actually QJ. I don't know who made. I've never heard of this one actually. So I've got this joystick, and I've got two more of the ones of the same brand of the other joysticks, which is actually Spectravideo. I think is that what it's called. Where does it say that? This is a quick shot, but that's not actually the brand name. I think it's called, is it called Spectravideo? I've forgotten the name of it. Anyway, they also made a computer at some point, or two. One of which actually came with a little joystick built in on the side. But I used to have one of them, but I sold it and I never got it to work because I didn't have the power supply. So anyway, one of these is apparently got a little piece of paper on it which says something about won't go down. So we're kind of going to see if that's actually the case. So we'll try this one first, and we're going to take one of these apart. So whichever one doesn't work, we'll take apart. We'll undo this. We'll plug in my thing to the joystick thing. So don't worry, I am going to make a more permanent version of this soon when I have the time, over Easter, probably. So this goes up, down, left, right, and this one works all perfectly fine. Look at that. That's nice. I think this is the model that I was thinking of. Well, this is similar to the model that I was thinking of. The one that was notorious for being a poor performer, as in breaking quite easily. They will all break quite easily. So this is impressive. This one still works. And this one has both buttons working. So they both do the same thing. There's no auto fire on that one. So that one was pretty exciting. So we can undo this one. So we can put that in the joysticks that actually work pile, and we'll have higher resale value. So I am thinking of selling these things. And so partly I wanted to just do this so that I can work out which ones work. This one, button doesn't work. It does go left and right. It doesn't go forward and backwards. So you've got two directions. If you're only playing a game, there's no other buttons, where you want to go left and right, this is the joystick to use. So the QJ Junior has lost out. It's got SV, so it might be a Spectravideo. I don't think it's called Spectravideo. It's called something else video. I wish I could remember. I would have remembered like 5 minutes before I started this video. So that one is not so good. So maybe that's going to be the candidate, because that's not like that's. I should dig up if I have any left, like in old school magazines about computers from the 80s. They would have like joystick like comparison chart things and reviews and everything, and I'm pretty sure this one will come out at the bottom if it's even in there. So that one can go to the side as the potential candidate. So this one here is apparently the one that doesn't go down. This one here, that is. And it has an auto fire, so I actually kind of want to take this one apart because I want to see the auto fire up close, and maybe to make an extra video to just do a bit of a circuit diagram. And it's going to be important to do the circuit diagram and just to make sure that I know how they did that, because an upcoming project is going to be to make an auto fire module so that you can plug any joystick you want in to the module, and then you plug the module into the computer, and then you can have your own little auto fire thing that you can turn on without the joystick having to do it. So that's going to be another project that comes up, but the first we have to do something else. But let's just test this one. So the button, oh, it's got one of these ones. This is what I thought it would work like. So I always imagine auto fire. So it does work. So if I turn off that, it's just a nice constant thing. And then if I turn it on, you get this flashing effect. So I guess there are two ways of doing an auto fire. One, you switch it on and it just stays on and it fires continually. And the other way is that you have to press the button down still, but it does it repeatedly. And I probably should point out, so I did draw a little chart. So we're just going to find out the down works later on. I don't think this is going to help at all. But the way that it's going to work on a little computer is that it's going to say, well, did you hold down the button? And then you're going to say, it's going to say yes, you pressed the button. So it's gone from being not held down to being held down. And then you might fire your bullet or something. But it might not do anything. It won't fire any more bullets until you've let go of the button. And so the button's being released. And then when you press it again, it will fire another bullet. So autofire works by automatically repeating that option. So if you weren't doing that, you'd probably have to do something like this, where you're continually pressing the button really, really fast with your finger or your thumb. And with these kind of joysticks, that can get really tiring really fast. So they could do it automatically for you. And so the two ways would be, it's always doing that, and the other way, which is what I preferred, which is that you hold the button down and it just does that. So if you turn off autofire, it's fine. So the other thing I mentioned yesterday was I thought that the timing, so this makes a lot more sense to me because it's quite slow in comparison to the one from yesterday. So yesterday we did a little thing with the oscilloscope, and it was going up and down like this. It was, so I look at the little black lines for a second, and they were roughly, well actually they were slightly longer than 10 milliseconds. So they would have been about, so this is not a very good diagram. But so we could just say it was like, I don't know, 13 or 14 milliseconds. So I've gone and done these the wrong way around. So what I was thinking on a computer, so on a British computer, and so these are British made design joysticks, I believe. Well, they're certainly not American branded, they're designed, they'll be like European. And in European places, their TVs, back then at least, ran at 50 frames per second. So PAL TVs and CMOS, I think in France, I don't know, I don't really know much about France. But anyway, they'd be 50 frames per second. And so the computer generally would be synchronized to the update of the screen. I'm just seeing how long it's just taking me to talk about it. And so you would usually check the joystick once every frame. And if you're doing 50 frames per second, at the top here, 50 FPS goes to 1000 milliseconds, divided by 50 is 20 milliseconds. So each little check, so this is a little green thing here, is the computer actually checking whether or not the joystick is pressed. And if you've got this fast pulsing here, what I was just concerned about, if it's so fast, it might be the case that you might check it and it will be in the pressed state, the high state here, but then it goes down and then it goes up and then you press it again. If it's too fast, you'll actually be missed. So what it will still think that you've got the joystick button pressed down, because when it's checking it, which is only once every so often in computer terms, electronics terms, then you are still seeing the same thing because you've missed the dip. But here I've drawn it so you have actually seen the dip. So you might get this strange beat frequency thing where you're reading it at a certain frequency, which is like a mixture of the two frequencies that these things are happening at. One day I might talk about this kind of stuff once I fully understand it myself. But the other way it might have happened is that you might have actually synchronized it so much that you hardly ever see it off, and so it's just mostly on. So the computer checking every so often, it would be not actually working. So it needs to be reasonably slow, like this one, I would have thought, such that the computer has, so that there is lasting a lot longer. So it's off, I'm not going to time it, but it's obviously off for a lot longer than 20 milliseconds. It's probably off for something like 100 or 200 milliseconds. So there's ample time, maybe even, I don't know, probably, I'm just guessing that, no idea. But I'm saying there's certainly enough time for the computer to say, oh yeah, it's gone off and it's gone back on again, I'm going to fire some more bullets. So that's what I meant from yesterday. So I'm really building the suspense here, because everybody's just saying, just make it go down. I want to find, there's a spider there, came out of the joystick. I just want to see if it goes down or not. So we're going to go left. It kind of goes left. Doesn't go left very well. It's going left now, so maybe it's a bit dirty in there. It looks like it's shimmering a bit, and it goes sort of to the right. Not a very good connection there. It doesn't go up, and it doesn't go down. So this one's pretty stuffed. I haven't broken it, have I? Because the other one wasn't going down either. So let's just get out my grid joystick. Just one last test, because the last two joysticks did not go down. So I'm just going to plug this one back. This is the one before. So this is the one I was just talking about with the fast auto fire and the non-working top button. But it does work. So my little joystick tester hasn't broken. So we can safely say that my joystick tester has come to the conclusion that this joystick is not so good. So we're going to try and take this apart. So we're going to switch off my joystick tester and we're going to put it to the side. And we're going to try and take this thing apart, and I probably can't do it because I don't have a sufficient supply of screwdrivers sitting on the table, except for this one, which hopefully, is that even a screw hole? Like, I don't think that is. I don't think that's just for decoration. And then it's got these silly suction cups. Oh, it's quite big screws, aren't they? They should be fine. This should be fine. Alright. So I had thought about it, that what I should do, of course, when you're doing these kind of things is A, get an electric screwdriver out, which seriously is not that hard. It's not that far away, and these are big screws. And by electric screwdriver, I just mean my drill. Or I could loosen the screws already beforehand, so it would be really, really straightforward to take the whole thing apart. Maybe we don't have to take the handle apart. It's obvious that the buttons up here work fine. So if we just take the bottom off, because I don't really want to take the handle apart, because I suspect it will just break and I'll never be able to put it back together again. And since this is a name brand one, and it looks pretty stylish, it's probably going to fetch a bit more money if I was to sell it. So we can see kind of here. So the trick with these things, and why these things are particularly bad, there's a lot of solder flux there. No one cleans these things. It looks like there is. Yeah, there's a big. You can't see that, I'm sure, on the camera, but there's a big splodge there. So I'm wondering if I spray it with some alcohol stuff, it will look nicer. So they don't have anything to clean. Oh, I do. Alright, well, we might do that. Let's just take this thing out. Well, this is harder than I thought. It's kind of stuck in there by something. This is not the channel to come to for unboxings. Come on, just come out. Oh, it's pulling on something. What's it actually attached to? Alright. Oh, okay, I think there's actually a bit of strain going there because it's trying to pull. Okay, we're going to have to take the handle out. Otherwise, we'll never get the rest of it out. I don't know if we're going to be able to do that unless we actually desolder the wires. You're not going to be able to see the other side of the circuit board very easily because it's kind of pretty. Ooh, I don't think I can. No, that's right. And thankfully, all these screws look to be exactly the same, so it won't be one of those things where I have to kind of work out which screw goes where. Which is good because that would be. I'm not good like that. I did take a laptop apart once, and like really all the way apart, and everything took apart. And I did put a lot of effort into remembering where the screws were, and I put it back together, and it worked better than when I took it apart. Actually, all the interesting circuits are obviously up here. So, but now we should have a bit of leeway because we can expand out the wire. So this doesn't look too hard to put back together, right? So it's got a little springy thing there for springy actions, but you can see how these things are kind of rubbish. I'm going to get out that other one, which has nicer, the better quality one. So this one here, I don't know if we're going to be able to see it, but it's got these little clicky switch things, and you can hear it. They're much sort of nicer switches, but these ones have these kind of rubbishy switches. To be honest, they look better than I thought they would. They do actually click. So this one isn't so bad. Some of them have these ones that are just pieces of metal that you just press down when you move the joystick. So they're really quiet. So I suspect this one here is one of those because you can't hear a thing when you move it. It's all just like moving around. This one here at least seems to click. So what would be possibly wrong with it? Well, we'll come back to that in a second, and we'll just use the multimeter to test that the connections work. And if not, we'll just spray it with some alcohol stuff, and maybe that will help. Actually, we can actually just plug it straight in a minute. But here we can see what kind of chip it's got, and this is kind of cool. So this is interesting. So this doesn't have a 555 timer on it. It has a 4069, which I think is quite cool. And that's actually kind of roughly the same as the 4049 that I've been doing a lot of on this channel. And so we haven't actually got around to the bit of making an oscillator out of a 4049, but we certainly are going to. So that's what they've used here. This is what I was thinking about. Would they be using one of these? And that's kind of interesting. So I don't know if the circuitry, is this going to come off very easily? Oh, we've got to take two more. So I'm going to hiccup. I don't think I'm going to have to like show me putting this back together on the video, right? Nobody's going to care about that. So there's the little switch. So that's how the little switch part works. And these screws are different, but I think I can remember that part. So taking that out, so there's a little switch that just goes backwards and forwards. And if we look at the bottom, so that's interesting. So those little wires go to the screw. Where did the screw actually go in? So I'm kind of interested about this. Is it using? No, that's underneath the IC. So what's the point of that? Are they not tying all their inputs to ground? Because there's a whole bunch, and then they link up in the middle, and I don't think they're actually connected to anything. We can probably guess. Let's just try. Where did I put my book? Which I just had. Hold on a second. I had to move it all the way over here. So it's my trusty CMOS cookbook. And we'll just get it to 4069. So I'm kind of interested in this. I know people want me to actually get around to fixing it. But if people do watch this. So 4068. 4069. So the 4069 is just a hex inverter like the 4049. It just doesn't have two non-connected pins, so it's only got 14 pins on it instead of the 16 of the 4049, and I think it's got slightly different electric quantities. This is a low power version of the 4049. So there you go. What have we got here? We've got this. So how are we going to work this one out? Because it's upside down. I don't know if we can really do the upside down things. Well, that's the chip there, facing it that way. I'm going to break these wires off, aren't I? So that goes there. So I feel like you have to, in order to do this, you have to kind of, well, we can do this. So that one there is going to, so the outputs are going nowhere. So that one's got a thing going to there. So we can assume that is probably ground or something. Well, no, they haven't tied the inputs of... Oh no, maybe they're using that one. I think so. So they're probably using that one. Well, that looks fine. It doesn't really matter. We'll come back to it. It's only got two. This is interesting. There's only two. That's probably like a 1 million. 1 million ohm resistor. We'll come back to that. I'm sure that's fine. We'll make that circuit real soon, I think, because we're going to, for that little game thing that I'm making, that little thing with the LEDs and the 7.4 HC595. What's all this stuff coming out of it? All right, so let's do this. Let's get out the whatchamacallit. So actually, when you look at this, so I'm going to bring this up really close. It's probably easier with that one there. So you can see how it works. And you press down the spring, it it clicks. So let's just plug it back in for a second. This is going to get messy. It already is messy. Where's the little plug? Move that there. There's the cable. And take that off. It's got more problems than just down. Alright, so now it should still work. Activate my tester. It's not a very good connection. That doesn't do anything. That one works okay. And that one doesn't. Is it actually showing up on the camera? Alright, cool. Oh, this is so terrible. So it feels like it can't all be rubbish. So okay. So what ones are actually connected to stuff? So that one goes through there, and that one goes through there. So those are all connected to ground. So we can kind of guess. That's right, it's got a black wire going into it. So those are all connected to ground, except for this one's a bit different, isn't it? That one, oh no, that one goes there. So they don't bother connecting these ones to ground. They just connect that one to ground. So that's fine. So how are we going to do this? So the first thing I just want to make sure is that so I'm going to do this here. I'm going to go to, if I left this thing on all night, I have again. Yes, again. The connectivity sensor, which sometimes works and sometimes doesn't work at making an annoying sound. I'm just going to test these two. Alright, so that's what it should say. So if I go to, so where are the little connector things? So that's the connector thing. So in the middle there's a little metal rod thing, and that when that goes down it touches it. Hey, look at that. Wow, wow, wow. What have we got here? That's quite nice. We don't have to do anything at all. Okay. They all seem to press it down. So they all work if you just press it directly. What if I used something that's not made of metal though? As my pen. Oh, the perfect thing. How much time we got left? A plastic camel, which I'm quite fond of this plastic camel. We'll use their legs to press it down. So I was just worried that I'm actually making a connection with the metal probe thing. So that's all working. So we don't actually have to test anything else, do we? It's got something to do with the spring here. So why doesn't that make a connection? So that's weird. It's like super weird. So if I press it down, so the little thing inside, if I press that down, it works. But if I press it down with the spring, it works now. It doesn't. It kind of works now when you do that. So I think we should just clean it. So weirdly, I do have everything for that. So I've got some cotton bud things, which are called something different in other places. Well, they call them Q-tips or something. All right, we've got some of this. So we'll just spray the whole thing. Spray it. We've drenched it over. All my fingers are. I've got a little cut on my finger. So that was a bad idea. That was a terrible idea. And then that's the wrong place to do it. No, it's not. Yeah, that's fine. It's not really going to get in there, is it? No, I think I just broke it. I did just break it. Now, how am I going to fix that? Okay, but that's not a good idea. So it just sort of shows you that I have no idea what I'm doing. So now I've got to get the little metal thing back in the right place. And I'm just going to use this little tiny screwdriver here, which seems like the best thing. I don't think I've broken it. I think I've just semi-broken it. But it looks like it's going to be a bit... Oh, there we go. And now it doesn't click. So how do you... Oh, I see what you got to do. Alright, we can do this. I hope I can do this, because I'm going to be really annoyed. I'd have to desolder the whole thing otherwise. it should pop up. Oh, my finger's hurting again. Oh well. I think I'm going to have to get a better video out of this one. This one is terrible. Alright. Come on, come on. Okay, oh no, it didn't work. Well, I've got this side up. Now, I know what we need. We need pliers. And probably several extra pairs of hands. Oh, actually, it's way easier when you do it this way, isn't it? It's still not going. Okay, you go there. And then it's got to go. This is going to go in the not really electronics channel. And it's just not exciting enough. You know, you're not like... Well, it's clicking again. And this time it works. And that works. That one doesn't work. And that one still doesn't work. So it probably does work. So why? Okay, what I am going to test. Hopefully all the alcohol is just dried off it. But I'm going to test what happens if I test as if there's a connection. Alright, so is there a connection between the little thing that pops down and the spring on any of these things? There is on this one. This is okay. And then if I do it on this one, so not really.